Hello everyone, welcome to OHM Institute. I am Shankar. In this video, I would like to discuss previous questions asked in the exam KPTCL, Karnataka Power Transmission Corporation Limited. So here I will take control system questions from previous years of KPTCL exam. Now let us look into the first question. In force current analogy, electrical capacitance is analogous to. So in this force current analogy, if you see mass represented with M is analogous to electrical parameter, that is capacitance. Next, spring constant K is analogous to the reciprocal of inductance. Next, viscous friction B is analogous to reciprocal of resistance. Therefore, for this question, the correct answer is mass. Capacitance is analogous to mass. Now, let us move to the next question. In the signal flow graph shown, x2 is equal to t into x1. That is what given. So, what do you mean by that? x2 divided by x1 is given as t. That means the transfer function is given. So we need to find out what is the value of t. Now from this signal flow graph, I can first identify that forward path. Generally it is denoted with m. First forward path m1, I can take forward path gain, that is 5. So in this graph there is only one forward path, therefore m1. Next, what is delta 1? 1 minus any loop gains which is not the part of first forward path. There is no such loops are there, therefore delta 1 is equal to simply 1. So there is no other forward paths. Okay, next let us find delta value. So these steps are to apply Mason's signal flow graph, Mason's gain formula by using signal flow graph concept. So what is delta here? 1 minus any loop. First we need to find out individual loops. What is the individual loop here? That is 0.5 loop gain, I mean. So there is no other loops and no non-touching loops also. Therefore delta value is simply is equal to 0.5. Delta value is simply 0.5. So here I can take delta value. Now what is the gain formula? x2 divided by x1, output node divided by input node will give you m1 delta 1, and there is no other forward paths, therefore m2 delta 2 not required, divided by delta. Therefore this value is 5 into 1 divided by delta value is 0.5. So this value is 10. Therefore what is the value of t here? That is 10. So answer is option D. Now let us move to the next question. As compared to a closed loop system, an open loop system is. So this question is basically on the concept of comparison of open loop system and closed loop system. Suppose if you look into open loop system, the basic idea here is, let me take open loop transfer function g of s. So what is the basic purpose here? A given system transfer function is expected to do some objective, some purpose. So here let me take output is c of s and Input signal is a R of S. So here this system will do its own defined objective, right? But sometimes it will not perform as per the required specification. For that, what is the basic information required? We need to place some controller before this system transfer function. That controller should have the information about the output function, output signal. So if this controller doesn't has the information on the output signal, then what will happen generally? There is a more chances for error. Therefore, what we can say, open loop system is less accurate. So there are two possible options here. If I apply elimination process, option A and C are not suitable because open loop system is less accurate. Okay. Now coming to the stability point of view, in general open loop system we can say it is a more stable, but sometimes open loop systems will also be unstable. By applying suitable feedback in a given system, we can improve the stability by using the closed loop system. But in general, in the very simple terms, we can say option here is a more stable and but less accurate. So that can be one appropriate answer. Next, coming to this signal flow graph, we need to identify. Let me read the question first. A signal flow graph is shown in the figure below. The number of forward paths is given with the symbol M. Next, the number of independent loops is referred with the P. For this signal flow graph would be okay. Now just for ease of understanding, let me give some symbols here. Let us say this is a G1, this is a G2, this is a G3. Next, this is G4. Next, this is a G5, G6. Okay. Now let us take this path is G7 and this path is G8. Okay. Now feedbacks, let me take with the H1 and H2. So first let us try to identify forward paths, that is M here. Okay. So let us try to identify forward paths. So one forward path, let us write with the M1. What is the first forward path I can say? That is G1, G2, G3, right? Next, M2, G4, G5 and G6. So what do you mean by forward path? We should start from the input node, that is R of t, and we should travel up to output node, but we should not traverse once again any loop, any node. Next, M3 we can say G1, G7, G6, M4, G4, G8, G3, M5, G1, G7, H2, G8, G3. Similarly, another symmetric path G4, G8, H1, G7, G6. Okay. So there are 6 forward paths in this particular signal flow graph. Now let us look into independent loops. Independent loops, that is P. Independent loops, that is a P here. So one is, let me use the symbol as P is given. One loop is G2 H1. Second loop is G5 H2. Second loop is a G5 H2. Third loop is G7 H2 G8 H1. So there are three possible independent loops. Therefore, option B is the correct answer for this question. Now, let us look into this theoretical question. Open loop control system does not have the following features. Does not have. So whenever in objective exams these type of statements, to be very careful. Sometimes mostly we will prepare what all the properties that open loop system will have or closed loop system will have. Not only this particular subject, in any subject, a given system or given concept, what are the properties, what are the advantages, disadvantages, like that. But in this type of questions does not have the following features. So that means out of the 4 options given, 3 options definitely properties of the open loop system. First let us figure out that. Open loop system is less expensive. Yes, that is less expensive. Therefore, it is not suitable for this question. In case of open loop system, disturbances causes errors because there is no feedback. So whenever any disturbance is created, there is more chances for the errors. Construction is a simple, that is a basic property of open loop system and easy for maintenance. To maintain the required quality in the output, recalibration is required for open loop system, but it is given it is not required. Hence, this is not the feature of open loop system. Hence, this will be the answer for the given question. Now, let us look into next question. Signal flow graph is used to obtain. So, basic function of signal flow graph is, suppose in order to find the transfer function of a given system, if a block diagram is given and if the system is very complicated, if it has multiple loops and more forward paths and all, in that case identification or calculation of the transfer function by using block diagram is somewhat laborious. In order to simplify to find the transfer function, basically signal flow graph will be used, and the gain formula was determined by Mason. Therefore, here answer could be signal flow graph is used to obtain transfer function of the system. That is the answer. Now, let us move to the next question. A unit ramp function, when integrated, it will give unit what function? Okay. Suppose if you write the expression for unit ramp function means 1 into t. 1 into t. Now integrate this one, integration of r of t dt. It will give you t square by 2. Okay. So basically this is nothing but a parabolic function. This is nothing but a parabolic function. Okay. This is a nothing but parabolic function. Therefore, answer for this question is option B. Now, let us look into the next question. The damping ratio of a system having the characteristic equation s square plus 2s plus 8 is equal to 0. So, first let us compare with the standard transfer function s square plus 2 zeta omega n s plus omega n square is equal to 0. Sorry, this is a characteristic equation of a second order system. So by comparing with that, we can identify omega n square is equal to 8. So from this we will get omega is equal to root 8. In other words, 2 root 2 units for omega, radian per second. Next, 2 zeta omega n is given 2. Therefore, what is zeta value? Okay, that is what is required from the question. Zeta is a damping ratio. Therefore, what we will get? 2 divided by 2 into omega n. What is omega n value we got? 2 into root 2. Therefore, here we can cancel this 2 and 2, and 1 by root 2 value is 0.707 divided by 2. So this will match with the option C. So this is a damping ratio, 0.707 divided by 2, 0.3535. So now let us move to the next question. The open loop transfer function of a unit feedback system is given by g of s. This is the given transfer function. This is the open loop transfer function of unity feedback system. What is the static position error constant Kp? So this particular question is from the error analysis in the time response chapter. So what is the basic definition for Kp? That is limit s tends to 0 g of s. Okay, limit s tends to 0 g of s. Therefore, if you substitute the given transfer function, limit s tends to 0, g of s is 50 divided by 1 plus 0.1 s into s plus 10. Okay, this is the given transfer function. Now by substituting s is equal to 0, what we will get? 50 divided by 1 into 10. So this can be simplified to the numerical value is a 5. So option A is the correct answer. Next, another question. If the characteristic equation of a system, we have already seen the similar model, some equation is given that is s square plus 8s plus 25 is equal to 0. What is the value of omega n, natural frequency? So by comparing with standard second order characteristic equation, I can write down omega n square is equal to 25. Therefore, from this we will get omega n is equal to 5 radian per second. Units are very important in the objective exam. Okay, so answer for this question is 5, option D. Next, now this question is from the stability topic, Routh's stability criterion. The first column of Routh table contains the following elements: 1, 2, 3, 4, 4, 3, 5, 1. The system is, now whenever we are finding a stability by using a Routh's stability criterion, what is the condition for stability? The first column elements, all the first column elements should have same sign. If any sign change is appeared in the first column, the number of sign changes will indicate the number of poles that are present in the right half of the S plane. But here if you observe the sign of all the elements of the first column, all are positive numbers. Therefore, there is no sign change in the first column elements, and hence we can say the given system is stable system. Okay, so answer will be option B. Now, a system with characteristic equation, let me write down a characteristic equation once. S cube plus 14s square plus 56s plus k is equal to 0. Now we need to find what is the condition for this system to be stable. So for that, what we can do, let us write down Routh's table. Let us write Routh's table. Okay. So how to write down Routh's table? First, S cube, row corresponding to S cube. Elements are 1, 56 here. Now the second row corresponding to S square. What is the element here? 14 and k. Next one, S power 1. How to find S power 1 element? 14 into 56. This is 784 minus k. Okay, how to find out this one? This element, you need to multiply this number and multiply this number. Okay, so denominator is 14 and here this element is not there. Next, S power 0 element, you can bring this k here. Therefore, what is the condition for stability? All the first column elements should have same sign. So as 1 and 14 are positive numbers, these two numbers should also be positive. Therefore, for stability, what is the condition? K should be greater than 0, and second condition is 784 minus k should be greater than 0. In other words, 784 is greater than k. Therefore, we can say the range will be, if k value, numerical value is in between 0 to 784, we can say the given system will be under stable condition. Okay. Next. Next question. The effect of addition of 0 to the open loop transfer function is. Now always remember these two statements. By adding pole, by adding a pole, what will happen? Root locus diagram will shift towards right side. Okay. Next, by adding 0 to a transfer function, root locus diagram will shift towards left side. That means more stable. So let us see the options. The effect of addition of 0 to the open loop transfer function will have an effect of pulling the root locus to the left hand side. So when the root locus is pulled towards left hand side, what will happen? The dominant pole real part will increase. See, for example, when the root locus diagram is for example something like this. These are the open loop poles. Now if I have a 0 here, then what happened? Root locus plot could be something like this. Therefore, when gain k increases, what will happen? The real part of the dominant pole will increase. So what is the settling time formula? 4 by zeta omega n. So when real part of the pole, dominant pole increases, what happens? Settling time will decrease. That means speed of the settling of response. Okay. Therefore, option C will be the correct answer. Next, which of the following is the best method for determination of stability and transient response? So the given options, Bode plot, root locus, Nyquist plot, by using all of these methods we will try to analyze the stability of a given system, but the transient response will be well analyzed by using root locus method. Therefore root locus will be the appropriate answer for this question. Next, which of the following is not in frequency domain? Okay, of course Bode plot, Nyquist criterion and polar plots, these are all frequency response analysis. Root locus will come under time response analysis. Therefore for this question root locus will be the best answer. So here time response analysis, root locus and RH stability criterion. Okay, coming to frequency response, what are all the concepts? Polar plot, Nyquist stability, polar plot, Nyquist stability. Next, Bode plot, these concepts will come under frequency response analysis. Next, which of the following is not in a frequency domain? Just this is one we discussed. This is a root locus. Next one, a minimum phase system with no zeros has a phase angle of minus 270 degree at a gain crossover frequency. Okay, so phase angle is given at gain crossover frequency is equal to minus 270 degree. Now what is the system stability condition? So by using this let us check phase margin. What is the definition of phase margin? 180 degree plus phase of the given transfer function at gain crossover frequency. Of course that value is given as minus 270 degree. So this is 180 degree minus 270 degree. This is minus 90 degree. As the phase margin is a negative, we can say the system is unstable system. Okay, next one. The frequency at which log magnitude, okay, the magnitude of the given transfer function in decibels versus frequency plot of a control system intersects 0 dB axis. See, for example, as per the given description, I can say this is a log magnitude plot. Okay, y-axis dB, x-axis frequency in a logarithmic scale. It meets 0 dB line. It meets 0 dB line. What is this frequency is called? This frequency is called gain crossover frequency. Therefore this is the answer, option A. Okay, that is the basic definition of gain crossover frequency. Now till this particular question, if you observe questions from the previous PSU exams, it is not more calculation based questions, but mostly these are the conceptual questions. Okay, if you are very familiar with the basic definitions, merits, demerits, and what concept to be applied for what purpose, these things are sufficient to crack this type of previous PSU exams. Okay, but here in these particular exams accuracy is very important because the cutoff will be very high. Therefore accuracy will be very important. Questions will not be so lengthy and not so much of heavy calculations, but mostly conceptual based questions. Now let us look into the next question. The Nyquist plot of loop transfer function g of s h of s of a closed loop control system passes through -1 point, that is the critical point in the Nyquist analysis. Now what is phase margin of the system? So what is given here, for example, this is a -1 point, -1 plus j0 point, this is the critical point. So when the phasor is crossing at this point, then there is no further improvement in the phase angle. Therefore what is the phase margin? Phase margin will be 0. That is the answer. Okay. Next, the radian per second phase shift of g of s is equal to 1 by s square. So if you write down the given transfer function in frequency domain, g of j omega is equal to 1 by omega square. Therefore what is the phase angle of this transfer function? This is minus 180 degree. The phase angle of this transfer function is minus 180 degree. Next one, the effect of phase lag network is. So some options are given. Now remember, phase lag, the basic properties, it will provide high attenuation at higher frequencies, high attenuation at higher frequencies. Because of that, phase margin will increase. Okay. Next, phase lag, another basic property is it will increase gain crossover frequency. Okay, it will increase a gain crossover frequency. Therefore correspondingly bandwidth will also improve. Therefore phase margin and bandwidth increases. Okay, so this could be the option. Now let us move to the next question. Polar plot of a sinusoidal transfer function is a plot of, the polar plot is nothing but magnitude versus phase angle. Magnitude versus frequency and phase angle versus frequency, these two together called Bode plots. Okay, these two together called Bode plot, right? Now gain margin, what is the basic definition of a gain margin? Instead of going through this theoretical statements, see, for example, this is the Nyquist plot of a particular system. Now let us say critical point is here, -1, right? And here this distance, let us say A. Okay, so in this particular diagram, what is gain margin? Gain margin is 1 by A. So what do you mean by this statement is a theoretical explanation. Reciprocal of the magnitude of the given transfer function at the frequency where the phase angle is minus 180 degree. The phase angle is minus 180 degree. That is option D. Okay. Next question, if the bandwidth of a control system is increased, then what is the basic result? Now remember, bandwidth and settling time are inversely related. Bandwidth and settling time are inversely related. So what do you mean by that? Bandwidth is increased means settling time will decrease. Settling time decreases means faster the response. Settling time decreases means response will be faster. Okay, so that is the answer. Next one, some transfer function is given. If this transfer function is a lead compensator, then what is the condition? Basically, for a lead compensator, what is the basic requirement? 0 should be right hand side, pole should be in the left hand side. But from this particular transfer function, where is a 0? 0 is at minus a. Where is the pole? Minus b. Therefore, for this transfer function to be lead compensator, what is the basic requirement? A should be less than b. Then only 0 will be towards the right hand side. Okay. So for this, option will be C. So what is the basic particular concept of lead compensator? Phase angle introduced by this compensator or this transfer function will be positive. Okay. Now let us move to the next question. The state space representation of a system is shown below. The eigenvalues of the system. What do you mean by eigenvalues of the system? Eigenvalues of the system are nothing but roots of determinant Si minus A is equal to 0. Okay. So first let us find out Si minus A determinant. Si minus A is equal to, how can I write? S 0 0 S minus A minus 2 1 0 minus 3. So this will give you S plus 2 minus 1 0 S plus 3. Okay. Now if you find out what is the determinant value here, S plus 2 into S plus 3 is equal to 0. So if you expand this equation, what you will get? S square plus 5S plus 6 is equal to 0. So what are the roots of this equation? S is equal to minus 2 and minus 3. These values are same as that of eigenvalues of the given system. Now let us move to the next question. If A is equal to some matrix is given, then the state transition matrix will be what is the state transition matrix? Expression phi of t is equal to e power at. This is nothing but inverse Laplace transform of Si minus A inverse. Okay. So let us find out first Si minus A matrix. Si minus A, okay, is equal to S 0 0 S minus. Now let us take A matrix given in the question, minus 1 0 0 minus 4. This will give you S plus 1 0 0 and S plus 4. This is Si minus A. Now let us find Si minus A inverse. So what it will give you for this first determinant, okay, 1 by, okay, let me write down. Numerator, what should I write? Adjoint of Si minus A. Denominator, determinant of Si minus A. Therefore, 1 by S plus 1 into S plus 4. 1 by S plus 1 into S plus 4 multiplied with adjoint S plus 4, 0, 0, S plus 1. Okay. Therefore, what is final simplification? 1 by S plus 1 will come here. This is 0. This is 0. 1 by S plus 4. So this is Si minus A inverse. Now what is state transition matrix e power At? Inverse Laplace transform of Si minus A inverse. Therefore, what is the inverse Laplace transform for 1 by S plus 1? E power minus t. This is 0. This is 0. And the last element will be e power minus 4t. So, which option is suitable here? Option A. Next, another question. The state variable description of a linear autonomous system is, this should be x dot. X dot is equal to Ax, where x is the two-dimensional state vector and A is the system matrix given by some A value is given. The roots of the characteristic equation are, what is the roots of characteristic equation? Determinant of Si minus A is equal to 0. These are the same as eigenvalues of the given state matrix. So, Si minus A matrix S 0, 0 and S. I am sorry, this is a determinant minus A 0, 2, 2, 0. So, it will give you S minus 2 minus 2 S. Therefore, what is the value here? S square minus 4 is equal to 0. So, from this we will get S is equal to plus or minus 2. Plus or minus 2. You should be careful here whether it is a plus or minus 2 or plus or minus J2. Minus 2 plus 2. This will be the answer. Okay. So, that's all we have previous questions in this particular KPTCL exam. Now, if you see the overall style of the questions, not so lengthy questions and not so heavy calculation based questions, mostly conceptual questions. If you prepare definitions, some sort of little bit equations and merits and demerits, then you can easily crack this exam. With this, I am concluding previous year question analysis on the control system subject. Thank you.